with these things, it's not like somebody sat down someday and decided, right, let's design this thing called edge computing. It's something where things happen and then we come up for a name and we come up with a paradigm afterwards once we've actually seen what's going on. So in the broadest possible terms, the internet has helped us to join our devices. Our network is one at the best of times. And what that means is that people require content. And whilst we enjoy the benefits of cloud services, the cloud isn't the best thing for everything, it turns out.
Hello everybody, and welcome back to another episode of Making It Happen by Sims. I'm here today with two very special guests. I have Rafael Bloom with me, and I have Balamayuran Sivapalan as well. Gents, how are you?
Hello. Very well, thank you. Good to see you, Drew.
Good. So before we go into introductions, I just wanted to give our audience a bit of an insight into today's podcast and its purpose, really. I think it's, for most of us, we might not have a true understanding of what edge and its drivers are, but we've certainly heard of edge. I think it's obvious to see that it's becoming more and more heard of, more and more utilized. Spending on edge is up like 15% on last year already in terms of hardware alone. So for the education part, it wasn't until I came across YouTube in searching for some answers on this, around edge and edge data centers in particular, that I thought no one's really talking about it that much, nor was there that great of explanations on it. And there wasn't really even a podcast either as well. And I think there's such great learning tools. So I thought with this, what better than to get you guys on to answer some of those questions with me, that I can personally benefit from, that I know our audience will benefit from. So without further ado, we'll get into that. So let's do some introductions. Rafi, if you want to kick it off, and then Bala, if you introduce yourself.
Sure. Good to be here. My name's Rafi Bloom. I am, I guess, a grizzled veteran of the data game. I started my career in the late 90s with Bloomberg, and I was with them for a good while. So learned lots indeed about various different models. One of the things that is pertinent today is that I used to look after Bloomberg TV, various aspects, and we use the content delivery network. So we'll talk about that. Since then, been involved with, these days, let's call it digital transformation. That means a lot of different things depending on what industry you're in. But yeah, I help organizations to make sense of their data from a regulatory standpoint. First of all, information governance and things like that. Long-term technology advice, but also I have a marketing and branding practice that comes off that, because I like talking about tech, and as you'll see. Thanks.
Yeah, that's why you're on, Rafi.
Yeah, thank you for having me here and for inviting me to this podcast. My name is Balamayuran Sivapalan. I'm coming actually from the IT support background. So I started as a first liner and worked my way to third line support, and then joined Kingston and started supporting the Kingston products. So more on the hardware side. So still doing the same type of support, but supporting the actual hardware, and sometimes involves software as well. And now I'm a FAE. So main purpose is really supporting all the Kingston products. So pre-sales and advising which products would be suitable for the different types of usage from customers. So my focus is really mainly the hardware and compatibilities. Sometimes involves some testing and also supporting them after sales.
Thanks for that, gents. So let's get into it then. I think the specific question and understanding I wanted to take away from today was specifically around edge data centers. But I think before we do that, we have to take a bit of a step back, and we need to sort of understand what's driving that, and that is edge computing. So Rafi, I thought it'd be good if we can kick things off, if you can give a bit of an explanation and understanding on what edge computing is and really the drivers behind it, and we'll have some discussion on that.
Sure, thanks. To understand it, as you say, you've got to step back a little bit. And firstly, let's just make sure that everyone understands that with these things, it's not like somebody sat down someday and decided, right, let's design this thing called edge computing. It's something where things happen, And then we come up for a name and we come up with a paradigm afterwards once we've actually seen what's going on. So in the broadest possible terms, the internet has helped us to join our devices. Our network is one at the best of times. And what that means is that people require content. And whilst we enjoy the benefits of cloud services, the cloud isn't the best thing for everything, it turns out. So what started to happen is, and I mentioned this Bloomberg example, I'll get straight to that. We used to broadcast, and I'm talking about early 2000s, so way ahead of the game. They used to broadcast Bloomberg TV, 5 channels of it, and transport all of the images, sound, all of the rushes, everything used to happen over the Bloomberg network, which is a privately owned network. So not many people were doing video over IP at that point. And what happened is that if you would tell users, hey, did you know that you can type a command on your Bloomberg terminal and get Bloomberg TV? They would say, wow, this is great. I've never had TV on my computer before. I know that sounds totally bizarre in 2022, but they'd say, wow. And then people would find out, oh, wow, he's looking at, watching video on the computer, same screen. It's great. I can have it up in the corner. Trouble, because delivering so much video content from a central location meant that you jammed up the network. Simple as that. And writ large over the internet, if you think about how much of the internet's traffic is video, if it were all coming from a central point and flowing on demand freely, it wouldn't work. So a content delivery network is where we decide to put the computation nearer to the user. So we would have sites that were close to the users, where those individuals who had requested video on demand would benefit from having a dedicated stream that was being shared by many users in that cluster and not taking up bandwidth through the rest of the network, which, if you imagine with Bloomberg, people are trading on that. So, if people gummed up the network, people started yelling and yelling quickly. So that was the beginning of it, let's say, again, broad pictures and writ large. Now what we have is a situation where it's gone further than that. Everyone is consuming video on their TVs and so forth, on their computers. That's a fact of life. But edge computing is taking a step beyond that and thinking about the device and the endpoint as being slightly more sophisticated than it was. So a good example would be your phone unlocking. So if you've got a face recognition phone to set up to unlock on your face, the computation that's required to do that, an AI process, it's pretty complex. False positives and false negatives are dangerous. It's got to be done right. It's got to be done quickly. Pushing that up to the cloud doesn't make for a great user experience. Simple as that. You wouldn't sell many phones if it had to go back up to the cloud, or we don't have connectivity today, or at the moment you're in a bandwidth dark spot. You can't use your phone. Sorry. Another one would be a car. If you buy, again, various brands of car are available, but if you buy a Tesla, one of the things that you become aware of in that experience is just how much sensing that car is doing. So collision detection. If you had to rely on the cloud to put the brakes on, right, that's really obvious. You need to have computation at the edge. And that's, again, really quick story, but that's what we're talking about here today.
Yeah, sure. So I think what I take from that in summary as almost is that, I think many industries and enterprise are going to use this, but it's kind of what we're looking to do is maximize operational efficiency and performance as well as safety. You mentioned that there with collision on. and just take that always on attitude a step further with Edge, and it comes down to latency, right?
In large part, yeah, latency, and that it's again, if you go back to 1982 and you showed me what you could do with the cloud, I'd probably be able to wait for a response from the cloud and still think it's pretty amazing. But we've become somewhat entitled, and we want our devices to react really, really quickly and dynamically.
Yeah, agreed. And I kind of think of it as well, not so much from a device end, but I think obviously I read something around Australia is absolutely perfect for the Edge, right? You know, they're not used to traditional cloud facilities, that kind of thing, but having local compute close to the consumer is just going to deal with latency issues massively, and it's sort of going to cover that ground. So surely it's going to be in demand there just as much as anywhere, right?
Sure.
Yeah. So in having mentioned Edge, and specifically we kind of touched on Edge data centers there almost to a point. Bala, I know you've got some experience as a field application engineer for Kingston, so you may have had conversations with people about this already or not, but I know Kingston do cover a lot on Edge on their portal. Could you possibly just give our audience an insight into specifically what an Edge data center might look like or what it is?
I mean, most of it Rafael already covered. So to go now more in depth in terms of how it looks like from the products we have to offer. So if we talk about the Edge, we already know that the computing is basically brought closer to the user or the application, which basically cuts the latency. Yeah, and with that, reducing the bandwidth required to go to the cloud itself. So now looking at the product perspective from Kingston, how they come in this is, so those servers or those computers, they will require some sort of memory or a storage. Yeah, so now memory is for the mostly anyway needed, but now looking at the storage, SSDs, which is performance driven, right? So and I will only concentrate on the NVMe because that's what is offered at the moment and being the fastest storage available, and that basically helps on the Edge to cache the data, so to keep up with the data streams coming to the Edge computation, which means it's really, there's data coming in from sensors, there's data coming in from video vision, like going on the example with the car, for example. So there's a lot of data coming to the system itself. So, and that data needs to be stored somewhere, which is mostly a SSD based or NVMe based storage. That could be a M.2 SSD, or it could also be a U.2, just as an example. And there's also other form factors available to use it as a storage. So this is now just on the Edge computing. So now taking up the first example with the content delivery network, it's interesting because you have different tiering models there as well. So you have the normal storage on the Edge computer itself, and then you also have the caching storage. So the normal storage may be of a normal standard SATA drive, but which runs the operating system or smaller applications. And now going at what needs to be available right away, or data that needs to be processed quickly or need to be accessible quickly, that could be now in the cache, and that cache be mostly NVMe SSD. So now, in terms of the data route between the Edge and the cloud, in the cloud itself, it could be actually sitting on a hard drive or a standard slower storage medium, because it depends on what type of data it is, and it transfers between the the edge and the cloud. And so the edge computing would basically cache everything what is needed immediately and what it can get on data locally and process it locally, and whatever information it requires from the cloud, it will get it from the back in the background. So
Sure.
as a user or from the application perspective, you wouldn't notice any difference in there. And because you have it at the edge, it basically it's seamless.
No, I agree. And thank you so much for that explanation. I just wanted to give our audience a bit of an insight. You know, everyone sort of in the past 4, 5, 10 years is just starting to get used to or fully understanding what the cloud is and understanding that situation in cloud facilities. Is someone able to give us a bit of an explanation? How does an edge facility differ to a cloud facility?
Bala, you want to take that? I mean, I was going to mention some of the physical things, the difference between running things on spinning disks and running them on SSD, just quickly, because I'm just thinking about the devices that we've got, right? If my first MP3 player, there was a hard drive in there. Again, if you think about your Tesla or any sort of device that's making any kind of decision, again, there are degrees to it. Like a Roomba is making a decision that's completely autonomous. You know, the consequences for being wrong. Just if you could imagine a car festooned with spinning hard drives, right? This is one of the things where we expect now our devices to go anywhere, right? So everything on tablets, everything that engineers are using, things that are in difficult environments, high humidity environments, or environments with vibration. A hard drive just is no good. SSD is you know, it's the ideal thing because it can be powered off. You know, it's noiseless. So many things about it are apt for the situation before you come to the fact that this is something that is capable of moving large volumes of data around locally. And that's that key process there where, so for example, if you think about cloud gaming or metaverse applications like a VR headset, the work that is being done locally, it's leveraging very large amounts of data in order to create that experience. So the question being about the form factor of a cloud data center and an edge data center, you know, I look at it from an environmental point of view. You wouldn't want to have that form factor, you know, roaming the streets.
No, for sure. And I do think back to obviously just what you're saying there in terms of difference to HDD, no moving parts kind of thing. But Bala, do you think SSDs are going to have to be even more robust in the nature as we move forward with technology? Obviously talking about vibrations, environmental things. Do you think even SSD is going to have to evolve further to deal with what the edge demand will be?
Most certainly. I mean, it's at the moment, it's I think it depends on the location or the environment where the edge computer is located, and having specific specifications. So to give like a simple example, so let's say it is an environment where it's very cold or very hot, or because you will always generate heat as a computer itself already, but then also the environmental, so the temperature around it plays a role as well. So for example, it could be that there will be some sort of a heating or cooling available at that location. But in case if that's not available, then the components used in the systems have to compensate. So it will really depend on where it's located. So accordingly, of course, the specifications need to evolve as well. So there is, for example, industrial temperature ranges for products, or there are specifications in terms of vibrations and even like I'm trying to think. I can't think of all of them at the moment from top of my head, but there are specifications available on specific products, and so we do have customers who ask for these specifications. Okay, can it withstand this level of shock, or can it withstand this level of vibrations? If it's, for example, something where there is vibrations expected, for example.
Okay, I'll give an example if I can. Let's think about the Elizabeth line that just recently opened. This is a brand new piece of infrastructure that's been designed entirely on digital platforms, and whereby the entire infrastructure, the whole thing from top to bottom, has been designed with sensors. Firstly, getting the thing in there when they were, they're drilling mere meters from existing running tube lines, right? To get that right, you need your sensors. And think about your underground, it's a huge drilling thing. You can't afford not to know if there's a pressure buildup, if there's water coming in, all of these things. So that's in the build phase. In the run phase, you have an entire, all the heating, ventilation, all of those things are now run as effectively edge deployments. You've got a whole bunch of sensors reporting in real time, and that enables the user at the operation center to know exactly what is going on throughout the entire network in real time, and to make decisions based upon that. For me, that's a really good example about how the cloud doesn't suit everything, right?
Yeah.
There you go.
Yeah, agreed. I think, you mentioned it there, I think transport makes up around 25% of spend on edge hardware currently at the moment, and that will probably only grow. I imagine that brings us on nicely to the next bit. I imagine that will bring up, I think as we move on, we'll have different businesses and industries be introduced to edge possibly. But outside of that example, have you got any other further examples, guys, of sort of business or industry use cases for edge right now?
Well, a similar one to the engineering surface, let's call it. Critical infrastructure, energy, gas, power, all of those things. The ability of technicians to see what's going on and fix problems is entirely, it's powered by, it's all on tablets. People are able to collaborate and see on some of these platforms, you can see all of the bits of infrastructure for the first time in a virtual space laid out next to each other. So when you're drilling, you don't make any mistakes. So, that's one. In areas sort of perhaps closer to the consumer, we have things like VR, the metaverse, and I know we're talking about very, very broad things, but 5G was supposed to be a big change in the Internet of Things. Again, that's a very, very generic term, and all of the things that we've been talking about fit into the Internet of Things. Of course, it's not just a consumer thing, but we're talking about a spread of a new generation of technology or technologies into the public sphere. So if you look at the way mobile phones are able to interact with the network, things like cloud gaming become possible, right? So I've got this little device, it's on the tube, it's connected to some, public Wi-Fi, yet I am still able to game. That is there's a patchwork of technologies in play there. But one of the things that you can't do without is the edge computing paradigm for that, and the ability to move large amounts of data around, which is, of course, to do with internal throughput of whatever device you're talking about. But the reason why you need big throughput these days is because you've got 1080p graphics running on. It's kind of pointless on a little screen, I always say, but that's the experience that's being delivered. And I think about things for the future. Where the smart city. Let's talk about things like that. The connected home. A lot of people run their home on things like Hive and Apple Home platforms. That's perhaps for the future.
Agreed.
Well,
Agreed.
Perhaps.
No, brilliant. Appreciate that muchly. What I wanted to just quickly touch on is we mentioned sort of digital transformation earlier, and it's kind of like we're in a constant state of digital transformation because everyone's moved hybrid. So that's digital transformation, right? But cloud has sort of brought it on as well. But sadly, we're in a cost of business crisis as such. How do we think edge computing is going to be affected by this in terms of how quickly we do continue to transform? The situation that we're in with, I don't want to say it, with a potential recession coming up, is it going to slow things down, or are we just going to continue on this path?
There's a lot to unpack there. Look, there's so many things that are facing us as a society. Obviously the energy situation, let's not touch that. But let's talk more about the economy in and of itself. Things like retail, right, which has been squeezed. The fact that people now want to work from home now that they've actually experienced it and seen that it isn't all bad. Because as I say, I deal with digital transformation. I joke that if I'd gone to the COOs or the CEOs of the organizations that I work with 3 years ago and say, what you really ought to do is to make everyone a home worker. You wouldn't get a single meeting.
No.
This is, again, something that's been thrust upon us. Look at the humble QR code, right? Dead and buried 3 years ago. And now it's a technology that's found a use case. The point here is that it's very, very difficult to make secure predictions at this point, about what's going to happen. But what we do know is that we've entered a phase of mobility. You really want to be able to do anything, anywhere, and have that flexibility to work and play, be entertained where you are. So yes, there's a lot that's happening that's mixed up. Let's not forget the edge paradigm is something that we called it that after it happened. Mm-hmm. So there's multiple things going on. And if you talk again about digital transformation, if you're a hospital, that means something very, very different to if you are a school, no less serious. So when you talk about how do people put edge to work for their benefit, it really depends who you are. If you are, an artist, edge can help you to collaborate with other artists. I'm a musician, and one thing that you've not been able to do is to go into a studio and play music with other people. So you now have very low latency, edge-powered collaboration platforms for musicians.
Sure.
Where there is a need, people will presumably come up with some response to that. The edge paradigm is here, and it's going to be part of anyone's solution to a problem.
And you've mentioned cloud not being right for some things. What is cloud right for right now, if it's not for all things? What would you say if you were going to split the strategy between edge and cloud?
That's really a good question. So it depends how fast you want your decisions made. Okay, so traditionally speaking, if I've got my data backed up or stored now actively on something, something like the Microsoft O365 environments, or people running there on G Suite, just to be fair to both sides there, you're probably totally content to have all of your data sitting on the cloud if you have to wait 5 seconds for a document to appear. It's really not such a big deal. Are you able to collaborate in real time with your colleagues on a Word document or a PowerPoint? Yeah, you can totally do that now. So again, it really depends who you are. We're talking about very long lasting and deep technology trends. So if you I don't know, if you are planning a new product or service, there's a big difference between something where it's contingent on a decision being made locally because there's the data is sitting there, or whether I'm running a regular, a B2B business. All of your data can sit in the cloud. It's not stuff that if it isn't delivered now, you're going to suffer a financial loss or a lack of efficiency. The cloud's still pretty good. But again, if I want my car to brake suddenly because a child's wandered into the road, I don't want to rely on the cloud for that one.
No, for sure. Bala, anything to add to that?
Yeah, I think Rafael already covered everything, but the only thing I would add really is I do think that they both kind of coexist. So there is the need for the cloud as well as for the edge, and in some way it depends on how the infrastructure is built up. They contribute each other as well, complement each other as well. So there is some data there will be still in the cloud. So let's just as a simple example, if something is not available on the edge, but it needs to be acquired from somewhere else, in that case the cloud comes in handy. Or the other way around, you've been working on the cloud, but then if something goes wrong with the cloud, you can leverage back to the edge to get the same data. So it's the I think it depends on the complexity behind the whole infrastructure, how it's structured, and that could be different from different use cases. So
if you think about AI, for example, like if you compare something like DALL-E Mini or Crayon, right, where the one you type in, please show me, a picture of literally anything, right, and the AI does its best to respond. You're happy to wait a minute for that picture to appear. But if I'm relying on an AI process to take a decision locally, right, so unlock my phone, again, that example, or clean up my picture, right? I've just taken a picture of again, not promoting particular phones or brands, but the one where you can airbrush someone out.
You would need the cloud for that.
Right. It's something which the experience leverages a technology. The technology has to be at the edge. Whereas if it's something where you are leveraging compute over a longer period of time, because maybe it's a more complex task, or because delivery of the result isn't as time critical.
Really appreciate that. And I just sort of think at the back end of this podcast, I want to look at the immediate future trends, really, and just bring it back to you, Bala and Kingston. You did kind of touch on it earlier, but what do you think you'll be seeing from, or what people can see from Kingston in the future, sort of adapt to this new edge way of doing things? What things do you have in the pipeline, if you can or cannot speak about that?
I think, to say it really simply without giving away a lot, I think we in the past and right now as well, we always tend to adapt to the demand out there. So that means like we monitor the market and we see, like, let's say, which technologies are more adopted or becoming more mainstream, or which form factors are more used, and we would then accordingly develop products or bring out products which will fit that demand. So in that terms, that's all I can actually say. I mean, there are things in the pipeline, and we do watch as well what is the next upcoming technology, and already start like looking into that direction. But it's actually the demand and the market which decides kind of what is needed at the time. At the moment, I mean, there's a wide range of products already available. So now thinking of IoT devices, if they have like some sort of storage locally, it's mostly micro SD. There we have our specific industrial type of micro SD cards, as well as consumer type of micro SD cards, which can be used in these IoT devices. And then the other one I already mentioned, which is SSDs.
Yeah.
So it depends. Simply said, so we have what is needed right now. There may be some form factors which we don't do, but that can come in the future.
Yeah,
but we will continue to monitor.
One thing about the cost of living crisis is that obviously your technology, if you realize you've got to replace your laptop, one of the things, the great option is to boost up your existing equipment by giving it more memory, right? So it's able that, even if the processor is an older processor, if you give that the bandwidth of having double the RAM that it had before, you will instantly find that your computer is actually not so bad. And the other thing in terms of storage, again, if you bought something a while back, obviously as the digital world becomes richer, file types and files in general get bigger, and again that puts a lot of pressure on devices. One of the most efficient ways of keeping hold of your equipment and without suffering any performance loss is to use high performance USB SSDs. So I do this, if you're buying a new computer, if you buy it with 256 instead of a terabyte, you'll probably save yourself about £800 current market price. And you can get yourself a terabyte of really quick outboard storage for probably, about a couple of £100.
Yeah.
So the memory SSD situation, it's really, really a very, very useful. It's a very, very useful way of boosting your device's power and capability.
Yeah, I think that's absolutely key. I think that might be just a way of thinking for the next 12 to 24 months. Instead of going out and buying new kit, what can you do with the current kit you have that you've not already been able to achieve? Would you agree, Bala?
Absolutely. And Rafael, you pointed out the obvious, really. And
that's what I do.
This is actually a very current topic we have here quite often, and we see it as well in terms of queries where people do want to know, like, okay, I've got this hardware, what can I do with it? Can I squeeze out the last bit out of it? And that's exactly what you can do. You can check if you can upgrade the memory or upgrade the conventional hard disk or spinning disk to SSD. If it's a desktop, you may even be able to use adapters to use even an M.2 if it doesn't have it. And there's so many different options available to really just squeeze out the last bit of the existing hardware. And this starts from standard consumers all the way to data centers even, where you can look at how you squeeze out the last bit out of your existing hardware. And we see these queries, and we are always available as well when customers want to find out what can I do with the hardware what I have right now.
I was going to say another really cool thing that you can do, if you're familiar with the Raspberry Pi, right? So this is really, a de minimis computer. So I work with one organization that's got its own edge setup, right? So they've got a bunch of screens as you come up into the office. They have screens, rather like on the underground where you've got the escalator and the adverts. They've got flat panels with content that is of their own creation, and they have all of this content stored and running locally. They're not pushing it from the cloud. It's all being done locally through Raspberry Pi that they control them through a cloud interface, but they're actually leveraging local compute, like a really powerful, mean little computer that just does one thing. I think that's again, another creative use of technology that, nothing to do really with the cloud. There's a lot of exciting things that you can do at the edge.
Yeah, agree. And I think, Bala, just going back to form factors, EDSFF sort of server form factors are going to become more important, right, for getting more out of less or whatever situation. So the E1S, E1L ruler situation, what do you think on those?
We personally, as Kingston, we don't have a product yet in that segment, but we are looking into it. And the difficulty is always to know which form factor will become the mainstream product. Obviously, so for example, we brought out the U.2, which kind of still capturing its momentum, sort of. It's growing. There's more customers starting to use it, but it still hasn't kind of established as the mainstream go-to storage as such, for example. And that's why it's to be seen how that next form factor, which one will actually take the mainstream spot. And we're still looking into that as well. And but I don't have any details on when we will have a product in that segment. But there is some interesting new form factors coming, and they make totally sense. But we need to see how quick that gets adopted by the mainstream.
Yeah, it will definitely be interesting to see what comes out in that field, especially dealing with specifically edge servers and things like that. So I really appreciate it, guys. I just want to sort of some closing remarks to round this up. Rafi, for those working or having businesses in travel or retail, healthcare, what would your advice be to them on an edge strategy right now, the steps they should be taking?
It's a great question. Again, those are very disparate fields, and one of the things that unites them all, let's say, is the need to make long-term technology decisions. So in my business, you know, when I'm dealing with banks and so forth, there's this expression, technical debt, right? So you invested £250,000 on this particular platform and this particular paradigm 3 years ago. Has that actually locked you in to a situation where you actually need to spend $750,000 to get out of it and start making your own decisions? So this is one of the things that's happening. The role of the IT manager, and I apologize to all of the IT managers that I know, but traditionally at least, their role was linked to the server room, right? There's physical stuff that they have to manage. If you'd asked an IT manager that's looking after a big server room, do you think your business should move to the cloud? Right? Their answer isn't going to be objective because they're firing themselves, right? Therefore, the role of the IT, it's less IT and more OT today, operational technology. The technology is a given. It's actually more about making decisions long-term that suit your organizational strategy, right? So what that looks like if you're a hospital, there probably is a lot of cloud in there, because I know that, you know, if you scan someone's dodgy knee, right, a DICOM slide, as it's called, is 1.5 gig, right? So I wouldn't recommend that those guys store everything locally. And indeed, one of the problems has been that they buy a scanner and it comes with, you know, a few terabytes of spinning disk. Well, what happens when that goes? So you need to take a very, very long term, 5 to 10 years, not 0 to 5 years, about what your organization is actually seeking to achieve. And then think about what's the best technology route to go down, depending very much on what it is that you do. If you make physical objects, it may well be that those things get kitted out with an IP address that they didn't have before. Whereas if you are, you know, if you are a printing business, right, you're still leveraging the physical world, right? That's again very random, but you know, if you're a printing business, that works great on the cloud. You know, you don't have to do anything really quick with the data, big heavy files. And you can really be anywhere in order to perform that service. So again, a bit of a lawyer's answer, it depends.
No, I appreciate that. That's absolutely fine. And you're pretty thorough there. So we've sort of touched on, well, I think we've really touched on edge computing and what the drivers are behind it, edge data centers specifically compared to what the cloud is and some of the components behind that and how things are adapting, the economics. Is there anything else that do you think would be worthwhile for our audience to hear about before we sort of close up?
Forgive me for having another point, but I mentioned the smart city a while ago, and one of the most high-profile smart city experiments was in Toronto, and I'll just invite viewers to go and look up and see what actually happened there. But as I said at the top, I deal with sort of information governance. And one of the things that people have to be aware of course, is that the product sometimes it's actually you. Looking at what data you hold, where you hold it, how you encrypt it for the long term, how you treat your own digital legacy is also perhaps not something for the cloud. But also privacy. So one of the things that if I had an entirely Internet of Things-ified home, right? It's tracking my movement. It's tracking, my body temperature, the level of alcohol in my blood, whatever it might be. This isn't all about smart cars and power stations, right? We are the users and it is our data. So that's one thing that I would add to the conversation, is that if this is all our data, if we're the ones generating all of this digital information, we need to think about how that's treated. So, change your passwords and use encryption, and make sure that if you're actually building these products and services, this idea of privacy by design, and making it easy for the user, for the individual, to govern what happens with their data. I think this is a key thing to add to all of this.
Brilliant. Thank you. And Bala, anything to close?
No, nothing else for me.
Oh, good. Okay, cool. Well, I really appreciate you both coming on. I thought that was a very, very interesting and thorough conversation. We touched on a lot. Is there any links or anything that you'd like me to send people to that might help you guys?
Kingston.com.
Yeah, exactly. Okay. All right. Thank you, guys. I appreciate it. And we'll speak soon.
Thanks,
Drew.
Cheers.